Okay, good afternoon, Pute. Today we are going to discuss about vector Tute. Actually, we have started to discuss the Tute. We have done, I think, nearly 20 MCQs, no? Okay. But so today we are going to complete the Tute, and as well as I have to discuss about vector questions in quick recap series, because there were some questionable questions. Okay, so I think those should be discussed with you. So today we are going to discuss vector Tute. Okay, Harry, shall we start? Shall we start from MCQ questions, Puta? Okay. We have discussed first 7 questions. First 7 questions and 8 questions will be discussed after doing equilibrium and part. Now then, ninth one. So what is the answer for ninth one? What is the answer for ninth one? Tell me, everyone. Aggal hadabu katti again. What is the answer for ninth one? There is a force F here. You are asked to determine whether it can be get by adding these 3 vector systems. Okay. There's answer. He's saying answer is 5. What about others? What about others? Your answers? Oh, correct, and there. There are 3 cases. F1, F2. F1, F2, then F2, F1, F2, F1. F2, F1. Okay. Okay. Now, according to this question, there is a force F into this direction. The question was, we have determined whether it can be get by adding these 3 vector systems. Okay. We know if we add F1 and F2, if we add these 2 vector system, the resultant force, definitely the resultant force should be in between these 2 vectors. Therefore, it might be go into the direction of F. Therefore, if we add these two vectors F2 and F1, we can assume we can get a force like F. Okay. So definitely the option number 1 is correct. The option number 1 is correct. So what about option number 2 and option number 3? Can you add option number 2 and option number 3 as it is? Can you add? Can you add option number 2 as it is? Can you do that? Oh, yes. Yes. How to add? How to add? How to add these two forces? Tell me quickly. How to answer that then? How to add these two forces? Polygon method. Polygon. Oh yeah, polygon method. Yes, that is one method. But the principle is the vector addition principle. Principle of vector addition. No, principle of vector addition. You know this one, me. This is the starting point. This is point of first vector. This is the starting point and end point of the first vector. And it is coincide. The end point of the first vector is coincide with the starting point of the second vector. Now there are two free ends. One is a starting point, other one is the end point. So if I connect these two, we will have the resultant force of the vector system, or the resultant force of F1 and F2. Therefore, the addition of F1 and F2 in this case, the addition of F1 and F2 might be into the direction of F. Therefore, we can assume that we can get a force like F by adding this vector system too. Therefore, this option also correct. It also correct. We can get a force like F by adding this vector system. Okay. There's another method. Actually, in this case, we have applied the principle of vector addition, the basic principle. Instead of that principle, we can apply vector parallelogram method. How to apply vector parallelogram method to this option? How to apply that? Can anyone unmute and tell me the answer? How to apply vector parallelogram law into this vector system? කාටද unmute කරලා කියන්න පුළුවන්ද? කොහොමද මම vector parallelogram law එක මෙතන දාන්නේ? How to apply vector parallelogram law?
Create in a rectangle.
Sorry?
Create in a rectangle.
I couldn't hear you, Buddha.
By making it as a rectangle.
Rectangle. Yeah, rectangle. But we have to prepare that thing, okay? The first thing, actually, if we want to apply vector parallelogram law, we have to prepare the vectors, two vectors, into the directions of two sides of a parallelogram. So how to do that? You know one thing here. These two forces are act on this point. These two forces are act at this point, no? The F2 force is act on this point. as well as F1 force. Okay. So we can slide these two vectors. We can slide these two vectors until we have this kind of figure. How to slide those two vectors? Without changing anything, I can slide these two vectors without changing anything of vector. Without changing means I won't change the direction. I won't change the line of action. I won't change the point of action. Keeping all the things same, I can slide one or two vectors to have this kind of figure. How to do that? How to do that? Look at this. If you slide F1 in this, if you slide F1 to up direction, then you will have this kind of figure, no? F1 here, F2 here. I didn't do anything to F2. I keep F2 as it is, but I shift F1 into upper direction. So I did not change the point of action. I did not change point of action. It is same as the previous one. Okay. I did not change the line of action. I did not change the magnitude and direction. So I did not change anything of this force. The only thing I did, I changed the arrangement. I changed the arrangement. Okay, I changed the arrangement because this is the arrangement what I know. No, therefore I changed the arrangement into this kind of thing. That is all. හරි කිසිම දෙයක් වෙනස් කරේ නෑ මම arrangement එක විතරක් වෙනස් කරා මම දන්න රූපෙට දැන් මම දන්න figure එකට arrangement එක වෙනස් කරා විතරයි කරේ හරි so line of action is same, point of action is same, direction is same, magnitude is same, but the arrangement is different. Therefore you can clearly see these two arrangements are same. These two arrangements are same. Therefore I can apply vector parallelogram law into this two vectors. So if I apply vector parallelogram law, I will have the resultant force into the direction of F. Therefore, I can have this kind of vector by adding F1 and F2 in option 2. Now tell me, what about option number 3? What about option number 3? Can you arrange that one like this? Can you arrange? Yes. How to do that? How to again pull on the? කොහොමද ඒක කරන්නේ arrange කරන්නේ කොහොමද කියලා? In this case, I have changed the arrangement of F1 only, F1 only. But if you want to arrange this one, you have to change both F1 and F2. You have to shift F1 into upper direction, and so F1 into upper direction and F2 into the right hand side. So if you shift F1 into upper direction, suppose this is point A, then I can draw like this. Now point A is at this point, F1 is here. If you shift F2 into the right hand direction, then again you will have same system. You will have the same system. Okay. Therefore, all the options means all the three cases are same. If you arrange all the cases like this way, then you will have the same resultant force. Therefore, we can have this kind of force by adding all three cases. Therefore, answer number 5. All are correct. Okay. Did you get my point? Everyone, I need responses. Thank you. Stu. Hello. Okay. Then number 10. Number 10. What is the answer for number 10? Number 10. Tanggal answer ටික දාගෙන යන්න එතකොට මට බලන්න පුළුවන් ඔයගොල්ලෝ කරාද කියලා ඔයගොල්ලෝ answer sheet
Yeah,
දුවේ
in the
නැහැ.
earlier question,
Sorry?
so in
Sorry.
the earlier question, answer C. If we don't change the side of it, sir, then we can't take it.
No, we can change.
Sir,
According
is it
to
a must to change?
according to question, it is clearly asked the force F shown in the figure can be obtained from. Therefore, we can obtain. This is only a drawing, no Buddha. This is only a drawing. Therefore, if we apply a force into this direction, that effect will be on the line of action. No, we can apply a force anywhere on its line of action. Therefore, its resultant won't be changed. If you don't change F2 and F3 in option C, if you didn't change F2 and F1 in option C, so how would you add those things without changing? Tell me that one. You can add option A and option B. You can add, and you can add without changing anything. But in option C, how could you add F1 and F2 without changing its arrangement? Tell me that thing. කොහොමද කරන්නේ? A and B අවුලක් නැහැ. A and B මට add කරන්න පුළුවන්. Without changing මට A and B add කරන්න පුළුවන්. අපි කරානේ ඒක. But C, how to add? මට add කරන්න බෑනේ. නේද? Did you get my point, Virat?
That means, sir, when we can't add it, we can change the direction.
No, I didn't change the direction. Again, I didn't. Did I change the direction? Did I change the direction? Did I change the point of action? Did I change the line of action? Did I? No, I didn't change anything. I changed only the arrangement, Puta. Only the arrangement. Okay? Did you get my point? Because according to the characteristic of force can be applied anywhere on its line of action. So we can apply this force anywhere on its line of action. Okay? So that characteristic can be used to add two forces. Did you get my point? As they are forces, I can use this characteristic because forces can be apply anywhere on its line of action. Line of action එක උඩ ඕන තරක force එකක් තියෙන්න පුළුවන්. effect එක වෙනස් වෙන්නේ නැහැ. තේරුණාද?
Okay, sir.
මතක තියාගන්න මම ඩිරෙක්ෂන් එක වෙනස් කරේ නැහැ පුතේ. ඩිරෙක්ෂන් එක වෙනස් කරෙත් නැහැ. මැග්නිටියුඩ් එක වෙනස් කරෙත් නැහැ. ලයින් ඔෆ් ඇක්ෂන් එක වෙනස් කරෙත් නැහැ. පොයින්ට් ඔෆ් ඇක්ෂන් එක වෙනස් කරෙත් නැහැ. මම එකක්වත් වෙනස් කරේ නැහැ. මෙයා පොයින්ට් මෙයාගේ පොයින්ට් ඔෆ් ඇක්ෂන් එක මෙතනම. පොයින්ට් ඔෆ් ඇක්ෂන් මොකද්ද? පොයින්ට් ඔෆ් ඇක්ෂන් එක මෙතනම. Did you get my point? Hmm? F1. So this is the point. This is the point. Okay. So point of action of F1 is this one. So I didn't change anything. I didn't change anything. I changed only the arrangement. Only the arrangement. And if you want to add two forces, you have to coincide their line, their starting point and end point. Hmm? You can go for the basic. Basic basic suppose there are two forces like this, F1. Suppose there are two forces like this. So what is the starting point of F1? Tell me the starting point of F1. I will let us. So what is this? Tell me, Buddha. What is the starting point F1? The starting point of F1? A. Starting point of F1 is A. End point of F1? This one, eh?
Yes.
So what is the starting point of F1? F2? F2? See, this is the starting point. So if you want to add these two forces, suppose there's a little bit separation. Suppose there is a little bit separation. Okay. I don't want to consider that one. Okay. If you want to add these two forces, suppose this is the first vector and this is the second vector. Or this is the first vector, this is the second vector. Anyway, anything. Okay. If you want to add these two, we have to coincide the end point of the first vector and the starting point of the second vector. That is the rule. So if you want to add these two, you have to coincide the end point of the first vector and the starting point of the second. Therefore, you have to shift F1 into upward direction. Then the starting point of the F1 will be coincide point of the F2. Then you will have the same result. Did you get my point? Tell this you. Okay. If you did not get the shifting case, then go for the basic. So what is the basic? If you want to add two vectors, you have to coincide the starting end point of the first vector and the starting point of the second vector. Okay. So if F2 is the first vector and F1 is the second vector, coincide the end point of F2 with the starting point of F1. Then you have to shift F1 into upward direction. Okay. Then you will have the resultant force into the direction of F. தெரியும்? Okay. 10th one. What is the answer? 10th one. Yes. Yes. Answer number 3, you can get it within your mind, no? You don't want to write anything. First, I will tell you how to get it using your mind without writing anything. Look at this. There are 3 forces, 8, 8, and 6. 8, 8, and 6. The angle between 2 8 forces is 120. Therefore, I know the resultant force of 2 8 forces should be equal to 8. Should be equal to 8. Then it says the resultant force of 2 8 forces is perpendicular to 6. That means the resultant is equal to 8, no? So 8 and 6 is perpendicular to each other. Therefore, the resultant should be equal to 10. Okay. Now I can do that thing. There are 3 forces, 8 Newton, 8 Newton, and 6 Newton. 8 Newton, 8 Newton, and 6 Newton. I'm really put a mind use karanna. Secondly, you can write that thing, write this thing in your book. Okay. But the first thing, try karan mind ekata. Mind ekema karan. Har mind ekema karan. Puluwan tarang. Har මම හැමදාම කියනවා මයින්ඩ් එකට අපි එක්සර්සයිස් එකක් දෙන්න ඕනේ. මයින්ඩ් එකට එක්සර්සයිස් දෙනකොට තමයි අපේ මයින්ඩ් එක ඉම්ප්‍රූව් වෙන්නේ. මයින්ඩ් එක ඉම්ප්‍රූව් කරන්න නැතුව මේ වැඩේ කරන්න බෑ. හරිද? මයින්ඩ් එක ඉම්ප්‍රූව් කරන්න නැතුව මේ වැඩේ කරන්න බෑ. මම හැම වෙලේම ඔක කියනවා. ඒක නිසා දැන් ඕගොල්ලෝ පොඩ හුරු වෙන්න ඕනේ. මම ඕගොල්ලන්ගෙන් එකපාරක බලාපොරොත්තු වෙන්නේ නැහැ. මම හැම වෙලේම කිව්වා මම ඒක මොකද ඕගොල්ලෝ වල ඉවරලා මේ ඒ වලට ඇවිල්ලා දැන් මේ සාමාන්‍ය ඉතින් අර හුරුලා ඉන්න විදිහත් එක්ක මම ඒක එකපාරම ඕගොල්ලන්ගෙන් බලාපොරොත්තු වෙන්නේ නැහැ. නමුත් try කරන්න. So how did I solve that part? According to the figure, according to given data, the angle between 2 8 forces, the angle between 2 8 forces is 120. So if the angle is equal to 120 of 2 equal forces, that means their resultant should be equal to the magnitude of one force. Therefore, resultant should be equal to 8. 8. We know that thing. Okay. Then it says the resultant of 2 8 forces is perpendicular to 6 Newton. That means the resultant is now 8, no? 8 and 6 are 2 perpendicular forces now. So 8 and 6 to perpendicular forces. That means the resultant should be equal to 8 square root of 80 square plus 60 square. That is equal to 100, no? That means answer is 10. So you don't want to write anything, but I will write this. According to figure, 2 8 Newton's forces, the angle between 2 8 Newton forces is equal to 180. I'm sorry, 120. Therefore, I know how to get the resultant force of 2 equal forces. 2p cos theta over 2, but you don't want to apply this equation because you should remember if the angle is 120 between 2 equal forces, that means their resultant should be equal to the magnitude of one force. You should know that part. You should remember that thing. You should remember that thing. So the resultant force should be equal to 8 Newton. Should be equal to 8 Newton. As this is a rhombus, this diagonal should be a bisector for this angle. That doesn't require. So after that data, it is given this resultant force is perpendicular to 6 Newton. It is perpendicular to 6 Newton. Okay. So if I take the resultant of 8 Newton and 8 Newton, now I can delete those 3 forces, no? I can delete now because I have taken the resultant of them. So now there are only two forces. What are those? 8 Newton and 6 Newton. 8 Newton means the resultant of 2/8, and this is the third one. So what is the resultant? The resultant is equal to square root of 8 squared plus 6 squared. That means 10 Newton. Eleventh one. So what is the answer for 11th one? Hmm? What is the answer for 11th one? The magnitude of the resultant of two forces of 10 kg and 9 kg acting at an angle of tan inverse 4/3 to each other. Now there are two forces 10 and 9. The angle between them 10th one. 10th one, no? Why? According to 10th, there are two forces acting at angle 180. 180. Sorry, 120. 180. Okay. So angle between two 8 forces angle between two 8 forces is equal to 120. So what is the resultant of these two forces? What is the resultant of these two forces? You should remember the thing. You don't want to calculate anything. If there are two equal forces acting at angle 120 degree, it should be equal to 8 Newton. Sorry, 8 Newton means it should be equal to the magnitude of one force. How to calculate that thing? Using this equation. 2p cos theta over 2. You can apply this equation. 2p means 2 times 8 into cos theta over 2 means theta means 120. 120 over 2 means 60. So cos 60 means half. Cos 60 is equal to half. Cos 60 is equal to half. So 2 to 2 will be cancelled out. This is equal to it. Actually, you don't want to calculate this one in the exam. You should remember this thing. Definitely, you should remember. Okay, otherwise, your time will be consumed. Okay, because we have done a lot of questions using this equation. And so, if there are two equal forces acting at an angle which is equal to 120 degree, definitely the resultant should be equal to the magnitude of one force. Okay. Now the magnitude of the resultant. The magnitude of the resultant is equal to 8 Newton. So I can use that instead of this one, 8 Newton. Okay, there is a 8 Newton force. 8 Newton means the resultant of the previous two forces. Now it says the third force, that means 6 Newton, is perpendicular to the resultant of the first two. Okay, that means the 6 Newton should be perpendicular to this 8 Newton force. 8 Newton force. 6 Newton is perpendicular to this 8 Newton force. So how to find the resultant of two perpendicular forces? How to find it? R should be equal to square root of p squared plus q squared. P squared plus q squared. Okay. So R is equal 80 squared plus 60 squared. That means 64 plus 36, 100. That means that is equal to 10. That is equal to 10. Did you get my point? 10 another issue.
So thank you.
Okay. Eleventh one. 11th one. Okay. Mm. All right. Now there are two forces, 10 and 9. 10 and 9, and angle is equal to tan inverse 4 over 3. Tan inverse 4 over 3. Okay. The angle between these, there are two forces, 9 and 10 theta. Angle theta is equal to tan inverse 4 over 3. Tan inverse 4 over 3. That means tan theta is equal to 4 over 3. If tan theta is equal 4 over 3, the cos theta should be equal 3 over 5. No, 3 over 5. How to calculate that thing? If tan theta is equal 4 over 3, that means this is the opposite side and this is the adjacent side. Opposite side over adjacent. Opposite over adjacent. Opposite over adjacent. So adjacent is equal to 5. If you want to calculate, if you want to find cos theta is equal adjacent over hypotenuse. Adjacent over hypotenuse. Now you know adjacent is equal to 3. The hypotenuse means 4 square plus 3 square is square root of. So that means it is equal to 5. Okay. So cos theta is equal to 3 over 5. Now you can apply that equation. No? So r squared is equal p squared. That means 9 squared plus 10 squared plus 2pq. 2pq cos theta. Cos theta means 3 over 5. So 2, that means 2 means 6, 12, 12, 12, 6, 12. 4 times 36. 36 into 3 means 108. Then this is 100. This is 81. So 181 plus 108. That means 289. 289 means R is equal to 70. 70. How? Theorem. R should be equal to 70.
Sir,
Yeah, yeah.
there's the 9 kilograms, so we have to change to Newton or not, sir?
No, you don't want to change Newton because answer is in kilogram. No? If you want to change Newton, then you can change. But after that, you have to convert it again into kilogram because answer is in kilogram. Therefore, you don't want to change that one. Okay.
Okay, sir, thank you.
Okay. Now, 12th question. If the maximum resultant of two forces acting at a point is 12 Newton and their minimum resultant is 4. So magnitude of two forces. How to tell me, how to get that one? Tell me. So what is the argument? What is the argument? If the maximum resultant force of two forces is equal to 12, minimum is equal to 4. Then I have to find two forces. So what is the logic? Here බලන්න ඒකේ තියෙන logic එක මොකද්ද කියලා කොහොමද අපි හොයන්නේ? Maximum resultant. The R max is equal to 12 පුතා. So how to build a relationship? How to build a relationship to find P and Q? P and Q means two forces. Tell me. Aggal kiya? මතක නැහැ දැන්නේ. ඔයා කොටු කරගත්තා අපි මං හිතන්නේ නේ. So what is the maximum? What is the maximum resultant force? What is the maximum resultant force? Yes, very good, very good, very good, very good. Addition and subtraction, very good, very good, very good. The maximum resultant force of two forces is equal to the addition of two forces, P plus Q, P plus Q. P plus Q is equal to 12. That is the maximum one. The minimum one is equal to the subtraction between them. To the subtraction, P minus Q is equal to 4. So, these two equations, if you add 2, that means Q to Q will be cancelled out. 2P equal to 16. That means P is equal to 8 Newton. That means Q is equal to 4 Newton. Okay. Okay. That means answer number 4, no? Another. Another. Did you get my points? If you have any doubts, please let me know. Then we can go for the next question. Eleventh one. Okay, okay. I will explain. I will explain that. Okay, according to 11th one, there are two forces, 10 kg and 9 kg. There are two forces, 10 kg and 9 kg. You don't want to convert that thing into Newton because my answers are in kg. Therefore, if you want to convert that one into Newton, you can do that. But after calculating the resultant force, then again you have to convert it into kilogram. So that is not required. Okay. Then the angle between these two forces is equal to tan inverse 4/3. Look at this. This is 10. This is 9. The angle theta. The angle theta is equal tan inverse 4/3. 4/3. So that those are the data that we have. So if you want to find the resultant force, definitely you have to calculate the cos value of this one, cos theta. No, you have to calculate cos theta. Otherwise, you cannot find the resultant, because now you know two forces. If you know two forces, now you have to calculate the cos theta only. If you know the cos theta, you can apply all the data into R squared equal P squared plus Q squared plus 2PQ cos theta equation. Therefore, you have to calculate cos theta. How to calculate cos theta? You have to calculate cos theta using this information. You know tan theta. Theta is equal to tan inverse 4 over 3. If tan inverse theta is equal to tan inverse 4 over 3, that means tan theta. So if tan theta is equal to 4 over 3, if I draw a right angle triangle, if I draw a right angle triangle, if I draw a right angle triangle, if it is theta, tan theta is 4 over 3. Tan theta is 4 over 3 means that opposite side over adjacent side. Opposite side over adjacent side is equal to 4 over 3. Then opposite side is 4, adjacent side is 3, or its integral multiplication. Okay. Therefore, if I take a right angle triangle, the opposite side should be equal to 4. The adjacent side is equal to 3. Or integral multiplication of them. Integral multiplication of them means it can be 8 over 6. It can be 12 over 9. That kind of thing. Okay. But the easiest way means we can consider it as 4 and 3. So if it is 4 and if it is 3, the hypotenuse is 5. Hypotenuse is 5. So you can calculate cos theta. Cos theta is equal the adjacent side over the hypotenuse. Adjacent side. Adjacent side is 3. The hypotenuse is 5. So now you can apply them into the equation. R squared equal P squared plus Q squared plus 2PQ cos theta. So R squared is equal 10 squared plus 9 squared plus 2 times 10 times 9 into cos theta 3 over 5. Okay. I think now you can do the calculation. Did you get my point, Puta? Okay. හරි. කාක මතක තියාගන්න ඕනේ අපි calculation කරද්දී පුළුවන් තරම් හිතෙන් කරන්න. Okay. මේ මම සමහර වෙලාවට මං හදන ගාන ඔයාලට හිතෙනවා ඇති ඔයිට වඩා පොඩ්ඩක් හිමින් කියා දෙන්නොත් හොඳයි කියලා. හරිද? ඒ වුණාට මං ඔයාලගේ මට්ටමට යන්න ඕනේ නැහැ. ඔයාලා එන්න ඕනේ මගේ මට්ටමට. මාත් ඔයාලගේ මට්ටමට ගිහිල්ලා මාත් පොඩි එකෙක් වුණොත් මොකද දන්නවද වෙන්නේ? අපි ඔක්කොම පොඩි උළුවේ. කවදාවත් ඕගොල්ලෝ හැදෙන්නේ නැහැ. හරිද? ඕගොල්ලෝ try කරන්න ඕනි මගේ මට්ටමට එන්න. නැත්නම් මං හිත විදිහට හිතන්න. හරිද? අනේ හොඳට මතක තියාගන්න. දැන් මං හිතුවේ කොහොමද කියලාත් මම ඕගොල්ලන්ට කියා දෙනවා. ඒක නිසා ඕගොල්ලෝ අනිවාර්යෙන් ඕගොල්ලෝ try කරනකොට ඕගොල්ලෝ මං හිතපු විදිහට හිතන්න. ඊට වඩා step එකක් ඉස්සරහට යන්න. හරිද? ඒක අනිවාර්යෙන් කළ යුතුයි. හරිද? ඒකයි මං කියන්නේ පුළුවන් තරම් questions කරන්න. මම මේ ඉංග්‍රීසි මීඩියම් එකට ඉංග්‍රීසි මීඩියම් දරුවන්ගේ මම මේ දැක්ක මේ පොඩි weak point එකක් මට ළමයි කීප දෙනෙක් කරුණාම තාම මේ ටියුට් එක කරලා ඉවර දෙමුන්නේ නැහැ. මම බලන්න අද මම අර මේකත් දැම්මා ඕගොල්ලන්ගේ මේ ක්ලාසස් වල ඕගොල්ලන්ගේ කරන්ට් ස්ටේටස් ටිකත් මම දැම්මා මේකේ සිංහල මීඩියම් කට්ටිය. ඒක almost okay. almost okay කියලා කියන්නේ මේ ඒ කියන්නේ 99ක් විතරම අවුලක් නැහැ. ඒ කියන්නේ ඔක්කොම ටික කම්ප්ලීට් කරලා දීලා තියෙනවා. සහ ඔක්කොම වලට මේ පාර්ටිසිපේට් වෙනවා. හැබැයි ඉංග්‍රීසි මීඩියම් කට්ටියගේ පෙන්ඩි ලිස්ට් එක ගොඩක් තියෙනවා. පෙන් ලිස්ට් එක ගොඩක් තියෙනවා. දැන් ඒක අතරම පොඩ්ඩක් අඩු කරගන්න වෙනවා. මොකද මේ මට පේනවා ඔයගොල්ලෝ තව ටියුට් එක කරලා නැහැ කියලා. දැන් මම ආන්සර්ස් අහනකොට ආන්සර්ස් දාන්නේ නැහැ. කීප දෙනෙක් ආන්සර්ස් දාන්නේ. හරිද? ඒක නිසා පොඩ්ඩක් ඒක ඔලුවට ගන්න, පොඩ්ඩක් ඔලුවට ගන්න කියන්නේ පුතේ try කරන්න. හරිද? මේ ඕන තරම් දරුවෝ ඉන්නවා try කරලා ඒගොල්ලෝ හදන ආන්සර්ස් ඒවට. ඒගොල්ලෝ හදන ආන්සර්ස් ඒපු ගමන් මට පැහැදිලිව කියා දෙන්න පුළුවන් ඕගොල්ලන්ට ඕගොල්ලන්ගේ weak point එක. ඒක මම කියන්නේ. මම හැමදාම කියන්නේ ඒකයි මට සබ්මිට් කරන්න ආන්සර්ස් ටික. හරිද? මට ඕගොල්ලන්ගේ ආන්සර් සබ්මිට් කරනකොට පුතේ මට බලන්න පුළුවන් ඕගොල්ලන්ගේ weak points. හරිද? ඒක නිසා ඔයාට හැදෙන්න ඕන නම් ඔයාට ඇත්තටම එක්සෑම් එක කරන්න ඕන නම් හරියට ඔයා අඳුර ගන්න ඕනේ ඔයාගේ weak points. එහෙම කරන්න ඔයා ටියුට් ටික කරලා මට එවන්න ඕන. ඒක අංක 1. මම අර නෝට් ටික එවන්න කියලා කිව්වේ නෝට් ටික එවන්න කිව්වේ අනිවාර්යෙන් නැත්තම් නෝට්ස් වල ළමයි අනිවාර්යෙන් ලියා ගන්න නැහැ. මොකද මේ රෙකෝඩින්ග්ස් දෙන නිසා ළමයි ලියා ගන්න නැහැ නෝට්ස්. කතන්දරේ. මම ඒක ස්ට්‍රික්ට් මේ රූල් එකක් දාලා තියෙන්නේ නෝට්ස් එවන්න කියලා ළමයි අනිවාර්යෙන් ඊට පස්සේ ලියනවා. ලියන්න නැතුව ඉන්නේ නැහැ. හරිද? හැබැයි ඒක විතරක් not enough. You have to send your answer sheets. Okay. If you send your answer sheet, then I can correct those things. Okay. If you may do some mistakes or if you may follow long steps, then I can advise you. Okay. Actually, you should may get my advices. Otherwise, how to improve yourself? How to improve? Well, so please send your answer sheets. Please send your answer sheet to check them. Okay. අර ආන්සර් ෂීට් එක ළමයිගේ මම චෙක් කරලා දුන්නා. චෙක් කරලා දෙනකොට අනිවාර්යෙන් මම ඒගොල්ලන්ට මොකක් හරි ඇඩ්වයිස් එකක් දීලාම තමයි මම චෙක් කරලා දෙන්නේ. හරිද? ඒ කියන්නේ අවශ්‍ය කියන්නේ හොඳටම කරපු කට්ටියට මම ඉතින් තේරුම් ගන්න එහෙම මේ අවුලක් කරන්නේ නැහැ. නමුත් ඇඩ්වයිස් දෙන්න අවශ්‍ය තැන් වලදී මම ඇඩ්වයිස් දෙනවා. හරිද? ඒකයි කියන්නේ. ඒ දේ අරගන්න. හරිද? එතකොට ඕගොල්ලන්ට පුළුවන් මං හිතන විදිය මොකද්ද කියලා අඳුර ගන්න. හරිද? ඒ නැත්තම් මං ආයෙසරයක් මම මේ කරන්නේ ආයෙ පාරක් අර අපි කියන්නේ බණ කියනවා කියලා බණ කීමක් තමයි මම කරන්න හදන්නේ. එහෙම කරගන්න එපා පුතේ. ඒ කියන්නේ අනිවාර්යෙන් ටියුට් එක හදන්න. හරි. මම ඔය පුංචි මේ කතාවක් එදත් කිව්වා අපි නිග්ලිජන්ස් කරොත් එහෙම මම ඔය නිග්ලිජන්ස් ගැන කතා කරනවා ගිය පාරත් කරේ. සමහර වෙලාවට අපි හිතනවා අපි අවුලක් නෑ අපිට කරගන්න පුළුවන් කියලා. ඔන්න ඕක හරි වැරදි සිතුවිල්ලක් සහ හරි භයානක සිතුවිල්ලක්. ඒක හොඳයි එන්නේ කොන්ෆිඩන්ස් ලෙවල් එක හොඳයි. නමුත් ප්‍රැක්ටිකලි අපි සෙල්ෆ් ඉලූෂන් එක කරගන්න ඕනි අපේ මට්ටම. මම ඒකයි ඔය මේ අර මොකද ක්වික් රීකැප් සීරීස් එක ගෙනාවේ හේතුව එතකොට මම කවදාවත් ඕගොල්ලන්ගේ ලකුණු ෂෙයා කරන්නේ නැහැ. හරිද? ලකුණු ෂෙයා කරන්නේ නැහැ. මම කරන්නේ ඕගොල්ලෝ පාර්ටිසිපේට් කරනවද නැද්ද කියලා ෂෙයා කරන එක විතරයි මම කරන්නේ. හරිද? ලකුණු ෂෙයා කරන්නේ නැත්නම් මට ඒක අවශ්‍යතාවයක් නැහැ. මට ඕගොල්ලන්ගේ ඕනි. මට එතන හදන්න ඕනි. පැහැදිලිව ඔයා you should do a self evaluation. That is a main objective of my quick recap series. You should do your on self evaluation. Because once you did the quiz, you can get understanding how to improve yourself. If you cannot remember the theory part of first 2 lessons, that means you forgot that thing, no? Therefore, you have to go through the notes or go through the videos again. Then you can understand how to improve that thing. Okay? So if you cannot calculate some resultant vector or something, that means you have to improve that part. Okay? If you continuously do some mistake in some particular subject area, that means you did not get that part. So likewise, you can do a self-evaluation from quick recap series. Okay, if you can do a self-evaluation, please do the basic. That means go for the basic. Means now you have enough time. Now you have enough time to recover. Okay, Puti? Because after 1 year or 1.5 year, you cannot recover. You cannot recover that thing. ඒ කියන්නේ අපිට අවුරුදු එකමාරකින් විතර වඩා recover කරන්න බෑ. හරිද? දැම්ම recover කරන්න පුළුවන්. දැම්ම ඔයගොල්ලෝ ඒ ටික අඳුරගත්තොත්. ඒක නිසා හොඳට තේරුම් ගන්න. ඔය කරන්ට් ටියුස් එක කරලා මට එවන්න පුතේ. මට එතකොට බලන්න පුළුවන්. හරි. හොඳයි. මම ආයේ ඒක මුත් කිව්වේ නැහැ. මට කීප දෙනෙක් ඒවා තිබ්බා. මම ඒ පුක ඉපදනාගේ සමාසමාතෙන් බැලුවා. තව තියෙනවා සබ්මිට් කරන්න. මේ හැබැයි හැමෝම පොඩ්ඩක් ඒක ඔලුවට අරගන්න, විශේෂයෙන්ම ඉංග්‍රීසි මීඩියම් දරුවෝ ටික. හරි. සිංහල මීඩියම් ඇත්තටම ඔයිට වඩා ගොඩාක් ඉස්සරහින් ඉන්නේ. ඒක හොඳට මතක තියාගන්න. හරි. මොකද ඕගොල්ලෝ මීඩියම් එක බලපාන්න එක්සෑම් එකට ගියාට පස්සේ කට්ටියත් එක්කම තමයි ලියන්න වෙන්නේ. හරි. ඒක පොඩ්ඩක් ඔලුවට අරන් ඉන්න. මෙතන ඉංග්‍රීසි මීඩියම් කට්ටියගේ නිග්ලිජන්ස් වැඩි. හරිද? බලන්න මම අර ඒපු ෂීට් එක ඇතිනේ. ඒපු ෂීට් එකේ පෙන්ඩි ලිස්ට් එකේ ඉන්න කොට දෙනෙක් ක්ලාස් වලට එන්නේ නැහැ, ලයිව් ක්ලාසස් වලට. රෙකෝඩින් බලනවා කියලා කියනවා. රෙකෝඩින් බලපු රෙකෝඩින් එකකුත් නැහැ. බලපු රෙකෝඩින් එකක් තියෙනවා නම් නෝට් එක ලියලා එවන්න එපා පුතේ. නෝට් එක ලියලා එවන්න නැත්තේ රෙකෝඩින් එක බලලා නැති නිසානේ. රෙකෝඩින් එක බැලුවා නම් නෝට් එක ලියනවනේ. නේ? ඒ කියන්නේ රෙකෝඩින් එක තාම බලලා නැහැ. ඉතින් force equilibrium linear motions රෙකෝඩින්ස් කීයක් තියෙන කියන්නේ? force equilibrium මම හිතන්නේ රෙකෝඩින්ස් 3ක් 4ක් ඇත්තේ. linear motion උත් එහෙමයි. linear motion උත් 4 වෙනි තියෙන්නේ. ඒක රිලීස් කරේ මේ ඊයේ පෙරේද? ඊයේ. පෙරේද 4 වෙනි මේකනේ. ඒක නිසා lessons 4යි තියෙන්නේ එකපාරට. lessons 4යි කියලා කියන්නේ දැන් මම මේක මාසයක් විතර ඉඳලා නම් මම මේක ඉන්ෆෝම් කරන්නේ. දැන් මාසෙක විතර ඉඳන් කරන ඉන්ෆෝමේෂන් මේ කරන ඉන්ෆෝම් එකවත් තව කම්ප්ලීට් කරලා නැහැ කියලා කියන්නේ තනිකරම නෙග්ලිජන්ස් තමයි. ඒ කියන්නේ ඒක ගණන් ගන්නෑ. හරිද? ඒ මං කියන්නේ ඉතින් ඒක ඒ තත්ත්වයට යන්න එපා. ඉතින් ඒ තත්ත්වයට ගියාට පස්සේ ආයේ පස්සට තව ටික කාලයක් ගියාට පස්සේ තමයි ඔක තේරෙන්නේ. හරිද? අපි දැන් අපි අඳුර ගන්න ඕනේ, දැම්ම අඳුර ගන්න ඕනේ අපේ වීක් පොයින්ට්. දැම්ම වීක් පොයින්ට් එක අඳුරගත්තොත් පුතේ දැම්ම දෙන්න ඉන්ජෙක්ෂන් එක. දැම්ම අනිවාර්යෙන් මේ සොලියුෂන් එක දෙන්න. ඒකට කල් ගන්න එපා. ඒකට කල් ගත්තොත් ඒ කාලය ඇතුළත තව දේවල් එනවා. දැන් මං කිව්වා දැන් මං ෆ්‍රයිඩේ පටන් ගන්නවා කියලා හීට්. මම ඒක ඕගොල්ලන්ට කීකියා හිටියද මාස ගානකට කලින්. පරණ ළමයි දන්නවා මාස ගානක ඉඳන් තමයි මම ওই ප්ලෑන් එක ගෙනාවේ. හරිද? මම දැන් මාස එකහමාරක් විතර තිස්සේ ඉඳන් ඕගොල්ලන්ව මේ ප්‍රෙෂර් කර අර නෝට්ස් එක ලියලා මේ ටික කම්ප්ලීට් කරන්න කියලා කියන්නේ මට අරක පටන් ගන්න ඕන නිසා. මොකද අරගේ බැලන්ස් වර්ක් සිබ්බොත් එහෙම පුතේ ඕගොල්ලන්ට ඔක කරගන්න බෑ. ඒක අනිවාර්යයි. හරි. ඒ නිසා මම ආශාවක් කියන්නේ බැලන්ස් වර්ක් තියාගන්න එපා. මම හොඳට මම කියන්නේ. හරිද? ඊට පස්සේ ඕගොල්ලන්ටම ඕගොල්ලන්ගේ මේ වැඩේ පාවෙයි. හරි? හරි. Okay, let's go for the 13th one. So what is the answer for question number 13? Question number 13. Tell me quickly. Question number 13. What is the answer? Yes, answer number 2. Answer number 2. Okay, look at this one. There are three forces like this. There are three forces like this. According to the questions, we are asked to find the resultant force of them. The resultant force of them. If you look into this figure, look at this. Newton. If you look into this figure, it says these three forces, these three forces are represented in magnitude and direction using a triangle. So they are represented in magnitude and direction. That means we can apply principle of vector addition or vector triangle theorem or vector polygon theorem. Okay, all are same, but if any vector system is represented in magnitude and direction, then we can apply that theorem. Then only we can apply that theorem. Okay. Because suppose the question says the vector system is represented using directions only. Okay. Suppose the vector system is represented in directions, not in magnitude. If it is represented in direction, then we cannot apply vector addition theorem. Okay. Then we have to go for the resolution method, because the vector system is not represented in both magnitude and direction. But in this case, it says the vector system is magnitude and direction. Then we can apply vector addition theorem. So if I apply vector addition theorem, you can clearly see 10 Newton and this 10 Newton are in same order, no? 10 Newton and 10 Newton is in same order. So that means we can add these two. If I add these two, the addition vector should be represented by AB. It should be represented by AB, no? This is AC plus CB. AC vector plus CB vector. If I add AC vector plus CB vector, these two will be cancelled out. Then I will have AB vector. This is the starting point. This is the end point. Those two are coincident. So AB vector. So AB vector is equal to the resultant force of them. I know the AB vector. It is equal to 10 Newton again. It is equal to 10 Newton again, but the direction is into the AB, into the direction of AB. So the AB vector is equal to 10 Newton into this direction. Therefore, the resultant of them is equal to 10 Newton into AB direction. So now there are two vectors. In to A to B direction. One is 10, other one also 10. 10 plus 10 means 20 Newton into A, B direction. So there the resultant force is equal to 20 Newton. The direction is from A to B. From A to B. So the answer is answer number 2, no? Answer number 2. Answer number 2. 14th part. 14th part. What is the answer? 14th part. Look like same question. 14th part. Others? අනිත් answers දෙන්න ඇත්ත කරලා නැද්ද?
Answer number
Answer number 3. 3. A, B, C. AB is 6 Newton. BC is 8 Newton. AC is 12 Newton. 12 Newton. Okay. It is the same theory. We can apply same theory. These two forces are in same order. So I can add those two, no? So I plus BC, it is equal to AC vector. So 6 plus 8 is equal to AC vector. It is equal to AC vector. The AC vector is equal to 12 Newton. It is equal to 12 Newton. So the addition of these two is equal to 12 Newton, and direction is from A to C. So I can replace these two by this 12 vector. So once I omit these two vectors, now there are two vectors into AC direction. One is 12 Newton and the one also 12 Newton. That means the resultant of them is equal to 24 Newton towards AC. Okay. So the answer is answer number 3. Answer number 3. Sorry.
Sir, can you please re-explain?
Okay. Look at this one, Buddha. Everyone, please look at the board. Okay. Now AB vector is 6 Newton, BC vector is 8 Newton. You can clearly see AB and BC. AB and BC are in same order. No? Is you can actually the end point of AB is coincide with starting point of BC. Vector is coincide with the starting point of BC. So if so, we are call it as same order. මෙහෙම ගියා. යන්න පුළුවන්. Okay. They are in same order into anti-clockwise direction. Same order. So I can add those two. If I add those two, that means AB plus BC. AB plus BC. If I add AB plus BC, the answer is AC vector. If I add these two, you can clearly see these 2 points are equal. That means they are coincide. So the addition vector is equal to the starting point and the end point. Okay. The addition vector is equal to the vector from the starting point and the end point. And therefore, the addition vector is equal to the vector from A to C. So the resultant, sorry? So resultant of these two, the resultant of 8 and 6 is equal to AC vector. The resultant of 6 Newton and 8 Newton is equal to AC vector. Now I have to find the magnitude of AC vector. How to find the magnitude? It is given. AC vector is 12 Newton. It is given. So AC vector is 12 Newton. So the resultant of these two is equal to AC vector. The AC vector is 12 Newton. It is given. But this 12 Newton force is another force, third force. Okay, third force. Therefore, if I consider the resultant of 8 Newton and 6 Newton, it is 12 into AC direction, and there's another force. It also 12. It is into the same direction. Therefore, the resultant of these two is equal to 24 into the AC direction. Then, did you get my point?
Yes, sir. Thank you.
Okay. Okay. We have done 15, 16 and 17. Okay. 18. Tell me, what is the answer for 18? 18. What is the answer? Answer number 2. Others? Hmm. Okay. The resultant force. How to calculate the resultant force? How to calculate the resultant force of this system? How to calculate the resultant force? Tell me. So, what is the easiest way? What is the easiest way to calculate the resultant force? Hmm? Tell me. How to calculate the resultant force? Come on, make resultant force से calculate करें.
By adding the components of the literal.
Sorry?
By separating the forces into components.
Yeah, resolve it. Resolve method. The easiest way is the resolve method. You can resolve forces into x and y direction. X and y direction. After that, you can get the resultant force. That is one method of taking resultant force. Why I am doing like this? Why I am doing like this? Why can't I use another method? You can clearly see these two angles are equal to each other. Equal to each other. Therefore, if I take the components in y direction and x direction, the two components of this 8 Newton and this 8 Newton should be equal and opposite to each other. Opposite to each other. Therefore, the y component of the system will be 0. Therefore, the resultant force should be equal to the x component of the system. That's why I use the system, because it is easy, because y components are cancelled out. Suppose now this is y direction, this is y, this one x. So if I take the component into y direction, you don't want to write this one. You don't want to write this one, but I will write, because you have to understand this thing. Therefore, this and the component y component of 8 Newton force is equal 8 sine 60. It is in upward direction, so it is plus. The y component of this force is in downward direction. No, it is in now downward direction. You have to bend into this way, downward direction. So it is equal to minus 8 sine 60. Therefore, y component is equal to 0. Now, the x component is equal to, you have to bend this 8 Newton into this direction. into the direction of angle. Therefore, it is cos 8 cos 60. Then again, you have to bend this force into this direction. That means into the angle. That means cos plus 8 cos 60. 8 cos 60. 8 cos 60. Cos 60 is half means 1. Therefore, answer is equal to 8 Newton. It is equal to 8 Newton. This is 8 over 2, 8 over 2, 8 over 2, 8 over 2 is 8. Right? Therefore, the x component of these two forces is equal to 8. Then the resultant. How to calculate the resultant? Now, here there's a force which is equal to 12, and here there's a force which is equal to 8 Newton. So the resultant should be 4 Newton into the left-hand side. 4 Newton into the left-hand side. Okay. There another. Did you get my point? Everyone? Okay. I just resolved these two forces, 8 Newton and 8 Newton into two directions. Okay. Then we can easily find the resultant force. All right. Okay. All right. Now we can go to the break. Break means quiz. Okay. Now we are down to 18th question. Then we can take a small break. A small break means you can. I will send the link for quick recap number 3, so you can do that one. So it is about 10 minutes, 20 minutes, 20 minutes, 25 minutes. Okay. So 9:20, you can come to the class again, 9:20. Now I will send the link. Okay, now I will send the link. Once you complete the quiz, please submit that thing. Okay, Buti? Okay, now I will send the link. Okay. You have to come again 9:20. Okay. Shall I do some question in Tute first? Then I will go to the review of quick recap series. Okay. The question number 19. Please do it quickly. Question number 19. So what will the answer? What is the answer? Question number 19. There are 3 forces acting on the same point. One is 1 Newton, other one is 2 Newton, and another one is 0.2 root 2 Newton. So what would be the resultant force? So what is the easiest method to get the resultant force here? The easiest method to get the resultant force? 1 Newton here, 2 Newton here, again 4 into root 2 Newton, the direction is 45. So how to get the resultant force? How to get the resultant force? What is the easiest way to get the resultant force? Tell me quickly. Then we can may go for the next step also. Okay. So may give me the answers quickly. So what is the easiest way to get the resultant force of the system? There are three forces, Nobuta. One is 4 into root 2, 2. Okay. So what is the easiest way? Actually, we can do two methods. No, we can apply two methods. The first thing is we can find the resultant force of 2 and 4. Then 4 into root 2 and the resultant of 2 and 2. 2 and 4. But the thing is, if I want to get the resultant force of 4 and 2, the magnitude can be get, because if magnitude is equal to the square root of 4 square root of 4 plus square root of 2. Okay. Sorry, magnitude of 4 and 2 is equal square root of 4 square plus 2 square. 4 square plus 2 square. But the thing is, even we get the magnitude, we don't know the direction. No, we don't know the direction. It is not equal, or it is not collinear with 4 into root 2 direction force. Therefore, it is actually finding the resultant of 4 and 2 won't be helpful. It won't be helpful. So, by looking into this figure, you can clearly see there is an angle. What is that one? 45. 45. And the magnitude comes with root 2. Magnitude comes with root 2. So, if I resolve this 4 into root 2 into two perpendicular direction, the root 2 will be cancelled out. No? Because this angle is 45. This angle is 45. Therefore, whether it is sine 45 or cos 45, it is equal to 1 over root 2. Therefore, if I resolve this force into x direction and y direction, root 2 will be cancelled out. Therefore, it is very easy to get the resultant force after resolving 4 into root 2 into the x direction and the y direction. If I resolve this one into x direction, you can clearly see, bend this one into this direction. 4 root 2 into cos 45. So if I get the horizontal component, or vertical component, or y component, it will be 4 45. Sorry. Therefore, the forces into x direction is equal to 4 plus this force. 4 plus this force. What is this force? 4 into root 2 into 1 over root 2. Therefore, root 2 to root 2 will be cancelled out. It will be 8 Newton. Then, y is equal to 2 plus this force. What is this one? 4 into root 2 sine 45. That means 4 into root 2 sine 45 means 1 over root 2. Therefore, 1 over root 2 will be cancelled out. The answer is 6. That is done now. That is very easy. There are two perpendicular forces. One is 8, other one is 6. Therefore, the resultant would be 10. No? How to get that one? Square root of 80 square plus 60 square. 80 square plus 60 square, that means that is equal to 10. Here, this is 8 Newton. Here, this is 6 Newton. So answer is R is equal square root of square 80 square plus 60 square. Actually, you don't want to write this one. You don't want to write this one. Actually, you can get the answer using your mind. Without writing single step, you can do that one. The only thing you have to decide how to get that one. Once you decide your option is, your method is the resolution method, then you can do that one using your mind. Look at this one. You know the component into this direction. Component into this direction is equal 4 times root 2 into sine or cos 45. That means 1 over root 2. Therefore, root 2 will be cancelled out. The answer is 4. Therefore, 4 first floor is 6, so 8. Then again, the result component in y direction, definitely root 2 will be cancelled out with sine 45 or root cos 45. Then 4 plus 2 means 6. 8 and 6. 8 and 6. The resultant is 10. Resultant is 10. Okay. 20th one. Okay, consider the following statement. The sum of two vectors always result a vector. Is that correct or wrong? Tell me, correct or wrong? Or true or false? Statement number 1, is that correct or wrong? Why is it false? The sum of two vectors is, suppose there is a displacement. If I add a displacement into another displacement, what will be your result? Is it a displacement or is it another scale quantity? It should be a displacement, no? That is the first rule of unit in dimensional analysis. If we add two, addition or subtraction can be done among two equal quantity, physical quantities. Addition or subtraction can be done among two equal physical quantities. That means we cannot add time into a kilogram. No, we cannot add, no, Buddha. We cannot add time into a liter. We cannot add liter with kilograms. So if you add or subtract, definitely both quantities should be equal and the resultant should be same. Okay. Here now. Therefore, addition or subtraction gives the same physical quantity. It won't be changed. Addition or subtraction give the same physical quantity without changing. Okay. That means if you add two velocities, you will have a velocity. If you subtract two velocities, again you will have a velocity. If you subtract two displacement, you will have a displacement. If you add two displacement, you will have a displacement. So by adding or subtracting, we cannot change the physical quantity. We will have the same physical quantity. The other thing is, we cannot add two different physical quantities. We cannot add time and kilogram. We cannot add. Therefore, if we want to add two physical quantities, those physical quantities should be same and should be same. Therefore, the statement number 1 is correct. The sum of two vectors always result a vector. Yes, correct. The second one, the product of a vector and a scalar always give a vector. Is that correct or wrong? Yes, that is correct. That is correct. If we multiply a vector with a scalar, it gives a vector. Very good. The product of two vectors always result a vector. See? Is that correct? True or false? Correct or wrong? See. False, false, false. What is the reason? What is the reason? What is the reason? Product. Product of two vectors. Actually, if we consider product, we know there are two kind of, actually three kind of, but basically there are two kind of product. What are those? Dot product. Other one is cross product. Dot product. Cross. If there is a product between two vectors using dot product method, it will result a scale. Dot product result a scale. The most common example is the work done. Work done is equal F into D. F into D, F means force, D means displacement. Force and displacement. If we consider force and displacement separately, those are vectors. But if we multiply those vectors using dot product method, it will give a scalar. Then cross product. The cross product. Cross product gives a vector. We can use same physical quantities. Suppose we want to find moment. Moment is equal F into D. F into D. F means force. D means the perpendicular distance. That means it is also a vector. Therefore, perpendicular distance means it also like a displacement. So this is a displacement. This is a force. This is a displacement. This is a force. We have multiplied two equal physical quantities, but using two methods. First one is dot product, other one is cross product. So if we multiply using cross product, we will have a vector. If we multiply using dot product, we will have a scalar. Okay. Now, there's another product type, another type of product. What is that one? Multiplication of a vector with another scalar physical quantity. Not just a scalar physical quantity like this. F equal ME. F equal ME. You know A is a vector. A is a vector. M is a scalar physical quantity, not just a scalar. Normally we call as a scalar that means it is a number. No? This is not just a number. This is another physical quantity which is a scalar. Okay. So this is a scalar physical quantity. So if any vector is multiplied by another scalar physical quantity, it gives a different vector. It gives a different vector. Initially, it was acceleration. Initially, it was acceleration. Once the acceleration is multiplied by mass, it becomes force. It becomes force. Okay. Another example. P into mv. P into mv means this is momentum. Momentum is equal to velocity into mass. Velocity, you know, velocity is a vector quantity and mass is a scalar quantity. So the product of those two gives another different vector quantity. Okay. There is another thing. Okay. මේ වගේ එකක් අහන්නත් පුළුවන්. හොඳේ. මේක එතන අහලා නැහැ නමුත් මේ වගේ දෙයක් අහන්න පුළුවන්. You have to mark them 20th. Okay. So shall we move for the quick recap series? දැන් quick recap series එකට ගිහිල්ලා එමු. ඊට පස්සේ ආයි වෙලාවක් තිබ්බොත් ආයි මේකට එමු. ආයි මොකද අපි දැන් question 20th වෙනකන් කරා 21st අපි කරලා තියෙන්නේ. Then so we have to start from 22nd question. Before that, we can go for the quick recap series. Okay. From the following physical quantities, the unit of impulse equal to the unit of impulse. What is the meaning of impulse? Actually, you don't know that thing, but I have given you equations. At the beginning of our classes, I gave the equations. The impulse means difference in momentum difference. Momentum difference within very short time is called as impulse. Okay. Therefore, impulse means momentum difference. It is equal to momentum difference. Difference in momentum. So if it is a difference in momentum, the result also a momentum, no? As I said earlier, if there is a subtraction between two physical quantities, it gives the same physical quantity. Therefore, if there is a momentum change, that should be equal to a momentum. Therefore, the dimensions of impulse should be equal to momentum. The second one, the dimensionally correct equation is given by dimensionally correct equation. How to get that one? You can use your dimensions. So the easiest way, you can use the units of these physical quantities. Units use kind of pull. The first one, actually you can omit first one. No, you know pressure is equal to force over area. Pressure is equal force over area. Therefore, the first one is wrong. Pressure is equal force over area, not force into area. The second one, power over volume. Power over volume pressure. Power means joule. Joule means this is the easy method, okay? Power over volume. Power means watt. Watt means joule per second. Joule per second. That means joule means Newton meter per second. Volume means meter cube. Meter cube. Okay, that is not equal to pressure, no? That is not equal to pressure. It is not equal to pressure because there is an S minus 1. S minus 1 won't be cancelled out. Okay. Newton, M minus 2, S minus 1. Therefore, there is S minus 1 putta. So, it is not equal to the unit of pressure. This is pressure. Eka pressure hai, but there is another small one. So second one is not the correct. Fourth one, you know the equation of fourth one, no? Impulse means momentum. It is a momentum, not a momentum difference. It is equal to momentum. Therefore, impulse is not equal to momentum times time. It is not equal. Fourth one, centripetal acceleration or force. Centripetal acceleration means it is an acceleration. It is an acceleration of force is not equal to mass. Okay. Force is equal to mass into acceleration. Okay. Therefore, that is not equal. Acceleration is not equal force into mass. That is wrong. Therefore, the correct answer would be answer number 5. It is energy over impulse. Energy over impulse. Energy means put a work done, no? Energy. Every time energy is a work done. Okay. You know this thing in your O level. Energy means it is a work done. So work done means Newton meter. It is Newton meter. Work done. Work done means force into displacement. Force. Therefore, this is equal Newton meter. Newton meter. Energy. Energy over impulse is equal to velocity. Energy over impulse. Impulse means it is equal to Newton second, NS, Newton second. So Newton to Newton will be cancelled out. Answer would be ms minus 1. So that is equal to the unit of velocity. Therefore, the answer number 4 should be correct. Should be correct. Answer number 4, not 4, 5. Answer number 5. Answer number 5 is correct. Third one, make good than a make answer first one, the healthy good. You QP. According to the given equation, R is equal Q over 2. R, this is R, that is equal Q over 2. R is equal Q over 2. So, if I find sin theta is equal to opposite side over hypotenuse. Now I know the opposite side is equal Q over 2 over the hypotenuse is Q. So, this is half. That means theta is equal 30. Then දැක්ක ගමන් 30 ගහන ඩෝංගල්. දැක්ක ගමන් 30 ගහන ඩෝංගල්. But the question is the angle between two forces. So how to find that angle between two forces? Angle between two forces. Is that 30? No. It is anti-clockwise, but the thing is, there's a way of measuring the Look at this one. This is Q. This is Q. This one is P. This one is P. Okay. Okay. So if you draw like this, is this the angle? Is this the angle? No. According to our definition of angle in between two vectors, it should be like this. It should be like this. No? So this is the angle between two vectors. So in order to determine the angle between two vectors, you should place two vectors like this way. Like this way means two vectors should be started from the same point. If they started from the same point, then you can measure them in anti-clockwise direction. Okay, that is a procedure. The first thing you have to do, you have to arrange two forces as they are acting from the same point. That means the starting point of those two vectors should be same. Okay, then we can measure the angle between two vectors. The first thing you have to do is the starting points. The starting points should be actually should be phi side. Did you get my point? Did you get my point? Otherwise, we cannot make a parallelogram. The first thing we have to make a parallelogram. Okay. So in order to make a parallelogram, we have to arrange this one, arrange these two forces like in this way. Okay. Okay. That is standard. අපි ඉතින් මෙතන 30 කිව්වත් ප්‍රශ්නයක් නෑ 30 කිව්වත් ප්‍රශ්නයක් නෑ නමුත් ප්‍රශ්නේ තියෙන්නේ ස්ටෑන්ඩඩ් එකක් තියෙනවා නැත්නම් එක කියන එක ඇන්ගල්ස් කියනවනේ දැන් ඔයා 30 කිව්වත් හරි කියලා කියන්න පුළුවන් කාටද මේකෙත් 150 කියලා කිව්වොත් ඒකත් හරි කියලා කියන්න පුළුවන් කාට හරි. Therefore we have to define a standard. Otherwise there will be various answers. Okay. So this is the standard way. Then you can play this one like this way. This is Q. This is P. This is Q. This is P. Then you can measure it from here to here. From here to here. So you know this angle is 30. So this angle should be 150. It should be 150. So answer is 150. Okay. Answer is 150. There now. Okay. Fourth one. බලන්න මොකද්ද කියලා තියෙන කියලා fourth one එකේ. 5 equal forces of 10 Newton each are applied at one point and all are lying in one plane. If the angle between the successive force vectors are equal, the resultant force will be. Now, there is a point here. 5 equal forces. One is here. Ding, ding, ding. Ding, ding, ding. F, F. Okay. The angle between forces are equal to each other according to given data. No? You know the angle around this point. Angle around this point should be equal to 360. So there are 1, 2, 3, 4, 5 angles. Therefore, one angle is equal 360 over 5. 360 over 5, that means 72. One angle is 72. Therefore, this would be, if one angle is 72, that means this should be a pentagon, no? It should be a pentagon. If I draw this one, into in a polygon. Okay. Again. Now there are 5 forces to be at. Okay. Now there are 5 forces to be at. So how to add them? We can use vector polygon law. So draw them draw the all forces in a polygon. Now this is the first force. This is the first force, F. This is the first force, F. Then this is the second force, F. You know this angle. The angle between them 72. Angle between them 72. Therefore, this side 18. 72. If you shift this force here, then two forces are like this. Therefore, this one is 72. Then the third force is inclined 72-degree angle to this one. This 72, 18. Likewise. One night. Then again, 72 here, 18 here. 72. This one from here to here, again F force here, again F force here, again F force here, because I know the internal angle is equal 198. Therefore, this should be a pentagon. This should be a pentagon. This should be a equilateral pentagon. Okay. This should be a equilateral pentagon, Puta. Therefore, it is very clear all the forces are in same direction. No, same direction means in order. All the forces are in order. All the forces are in order, and they started from here and ended from here. That means this is a closed loop. This is a closed loop. So the resultant is 0. The resultant is 0. Another. Did you get my point? Others? No. Area. Newton and where put it? I may come close loop then. Methane patangara, methane even a close loop. So starting point and end point are overlap. Therefore, if it is a closed loop, that means the resultant is 0. The resultant is 0. Look at this one. Suppose there are three forces to be at. Suppose there are three forces to be at. One is like this. Other one is like this. So how to add these three forces? The first thing you have to do, you have to coincide the end point of the first vector and the starting point of the second vector. You have to coincide these two first. Then you have to coincide this one and this. Now you have coincide. Once you coincide each endpoint and starting point up to the last vector, then you will have a gap here. You will have a gap here. The one corner is a starting point. The other corner is an end point. So if you construct a vector from starting point to end point, that would be the resultant vector of this system. Resultant vector of this system. Suppose there is a vector system that the resultant force of them is equal to 0. If the resultant force is 0, that means this gap should be 0. This gap should be 0. If this gap should be 0, if this gap is 0, that means this force should be like this. It should be like this. No? So if we have this kind of loop, that means this is a closed loop. Look at this. All the forces are in order. All the forces are in order. මේ පැත්තටම යන්නේ මේ. මේ එකම පැත්තට යන්නේ. All the forces are in order. If all the forces are in order, that means the force system is a closed loop. It is a closed loop. That means the resultant is 0. The same thing happened here. Same addition. If there is a closed loop, definitely the resultant is 0. Okay.
Okay.
Okay. Fifth one. Now you can apply that theory into this in this question. Now you can apply that theory. If you are given this kind of figure, as I told you earlier, you have to identify whether there is a closed loop or not. If there is a closed loop, that means the resultant is 0. Then you can omit that loop. Look at this. Is there any closed loop? I don't think so, no? Here, here, here. B, A, E, no, okay. A, B, C, D, F. As I told you earlier, if you are given this kind of vector system, the first thing you have to do, you have to look at whether there is a closed loop or not. If there's a closed loop, you can omit all the forces because their resultant should be 0. Look at this one. Is there any closed loop? No. No. No, there is no any closed loop. If it is a closed loop, all the forces should be in order, in same order. All forces should be in same order. But if you take these two forces, they are in same order, but this is in the opposite order. If you consider these two forces, they are in same order, but this one is in opposite order. So likewise, there is no any closed loop. Then, as I said to you earlier, then you have to consider the maximum number of vectors which are in same order. Then you have to consider the maximum number of vectors which are in same order. එකම order කියන vectors වැඩිම ප්‍රමාණයක් කරගන්න. හරිද? බලන්න. If you go through like this one, this one, this one, this one. Now 4 vectors are in order. 4 vectors are in order. මං කොහොම මේක බලන්න ලේසි විදියක් මේ බලන්න මේ මෙහෙම යන්න මෙහෙම යනකොට මේ ඊතලේ තියෙන මේ පැත්තට ඔන්න යන්න දෙනවා පුතේ ඔන්න යන්න මේ මෙයා යන්න දෙනවා මේ පැත්තට උනොත් යන්න දෙන්නේ නැහැ මේ කට වැහිලා ඒක නිසා මේ පැත්තට යන්න බෑ මේ පැත්තට යන්න හරි ඔන්න යන්න දෙනවා මුත් යන්න දෙනවා හරි උඩට යන්න බලන්න බෑ කට වැහිලා මේ පැත්තට යන්න බලන්න බෑ කට වැහිලා එහෙනම් මෙතනින් කට වැහිලා okay so that is the way of it is a simple way මේක නිකන් අර ටක්ටික් ක්‍රමයක් theory නෙවෙයි okay so go through like this you can see this arrowhead that allows you to go through it then come to this one you can see this arrowhead it allows you to go through it now you can come to this one look at this the arrowhead is in opposite direction, so he don't allow to go through it. But this one, you can go through it. Then this one, it allows you to go through it. Now you come to this location. Try to go through them. No, he don't allow. Try to go through them. No, he don't allow. So this is the end point now. You cannot go beyond that point. So those four forces are in order. Therefore, the resultant of them is from the starting point to end point. This is the gap now. So BD is the resultant of this one. Therefore, now you can omit these four forces. Now you can omit those four forces. Now this is BD. Look at these two forces. Ding, 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 ding. So what is the resultant? BF, FD. The resultant should be BD. It also equal to BD. Now you can omit these two. Now there are only two forces to be considered. This one. So these are in same order. So the resultant should be in the opposite order. That means it also equal to BD. Now you can omit these two. Now there are three forces. All the three forces are into BD direction. Therefore, the resultant should be equal to 3 times BD. Therium. Did you get my point? Everyone. Thank you. Hari. Okay. The second recap, I will do the fourth question first. Because it is something very special question. Okay. Question. Mami kita kata kara ada ini. To AB. Iya. FA. FB. Okay. How to do this kind of one? Okay, if you know this thing, sorry, you know this thing. If there is AB plus BC plus CD plus DE plus EF plus FA. So if you have this kind of arrangement, that means all are in closed loop. Therefore, I can consider the resultant force is equal to 0. But the thing is, now there are 2 AB, 2 BC, 2 CD, 3 times DE. How to add those one? Okay. Look at this one. Suppose A plus B plus C is equal D. Suppose there is a algebraic equation that is A plus B plus C is equal to 3. So if I multiply the both side by 2, then 2A plus 2B plus 2C should be equal to 2D, no? Should be equal to 2D. Right? So same principle can be applied in vectors. Look at this. 2A, 2B, 2CD, 2CD. If there is 2DE, if there is 2EF, then the resultant should be equal to DF, no? Sorry, AF. F. And look at this one. So 1, 2, 3, 1, 2, 3, 2AB, 2BC, 2DC. So I can write 3DE as again 3FE equal to FE plus FE. F. Okay, now consider all the 2 cases, 2 times cases. That means this one, this one, this one, this one, and this one. If I consider those cases, you can clearly see this is the starting point. Oh, come on. මෙන්න මෙයා ගියා, මෙහෙම ගියා, මෙහෙම ගියා. බලන්න පුතේ. මෙහෙම ගියා. So, මෙන්න මෙතනට ආවා. So, this is the starting point, this is the end point. This is the starting point and this is the end point up to A, up from A to B, C, D, E, F. All the vectors are in order. Therefore, the resultant should be from the starting point to end point, it is equal to AF. 2AF. It is equal to AF, no? All are 2, no? A plus B plus C is equal to D. So 2A plus 2B plus 2C equal to D. Likewise, 2AB plus 2BC plus 2CD plus 2DE plus 2FE plus is 2FE is equal to 2 times A. Therefore, all the 2 values can be replaced. Now this is not here. This is not here. This one is not here. In here, 2DE, no, there's no 2DE, but still there's DE. Still there's DE. Balance one. DE. Now there's no 2DE, 2EF, but it's still 1 EF. That's 1 EF. Okay. Now, from here to here, 2 FA here, FAF here, and 1 FA into other side. Therefore, the resultant would be 1AF into A to F direction. A to F direction, two vectors, two A, and the opposite side 1. Therefore, now them means AF from here to here. Okay. Now you can consider these 4. 1, 2, 3, 4. All are in same order and they make a closed loop. They make a closed loop. Look at this. They make a closed loop. Therefore, the resultant of them should be equal to 0. So I can omit these 2 forces, 4 forces. The resultant of them is 0. So now there are only 2 forces. One is A to F. Other one is F to D. Other one is F to D. Now they are in order. Therefore, the resultant should be from the starting point to end point. That means A to D. A to D. A to D. Here or not? Did you get my point? Therium. Therium. How's Okay. හොඳයි. බලන්න පුතේ අන්තිමට මෙන්න අපි මේකට හදලම නවත්තු. fourth one. මේ සිංහල මීඩියම් පේපර් එකේ ගානක් මම කිව්වා පොඩ්ඩක් ඕගොල්ලන්ට බලා ගන්න කියලා. මේකත් විශේෂ ගානක් පුතේ. මේක අපි මේ එක්සෑම් ක්වෙස්චන් එකක්. මේ වගේ ක්වෙස්චන්ස් හදන්න අපි දැනගෙන ඉන්න ඕනි. මේක එක්සෑම් ක්වෙස්චන් ටැබ් මම අර ඔක EQR එකට දානවා කොහොමද? මේ එක්සෑම් ක්වෙස්චන් රිවිවිං එකට දානවා කොහොමද? නමුත් ඊට ඉස්සෙල්ලා පොඩ්ඩක් බලමු ඒක කරන්න කියලා. මේ ගොඩක් වටිනවා. මොකද ඔයගොල්ලන්ට සාමාන්‍ය එක්සෑම් එකට එන්න පුළුවන් ගානක් මේ ටර්ම් ටෙස්ට් වලට. Look at this one. According to the given question, those forces are drawn according to their magnitude and direction. Therefore, the lines mentioned in this figure represent a vector in magnitude and direction. So their lengths are corresponding to the magnitude of force. Okay. මේ වගේ තැනකදී පුංචි දෙයක් කරන්න තියෙනවා. You can use ruler. If you can if you can use your mind, then ruler won't require. But the thing is, if you want to use ruler, you can use ruler because they are representing in magnitude and direction. Magnitude and direction. So the length of this vector should be corresponding to the magnitude of that vector. Now look at this. You can clearly see this force F1 and F5, you know. 1, 2, 3, 4, 5. F1 and F5. F1 and F5, you know. sorry, F2 and F5. F2 and F5. F2 and F5. Look at this one. If you can use your ruler, then you can do that one. Okay. But by seeing into this figure, if you closely see into this figure, look at this one. F2 and F5. F2 and F6. F6. 2, 4, 5, 2, 3, 4, 5, 6. Sorry. 2, 3. Hurry. F2 එකයි F6 එකයි බලන්න. If we consider F2 and F6, you can clearly see they are equal in magnitude and opposite in direction. So you can omit these two forces. Then F3 and F5. F3 and F5, if you closely look into these two forces, you can clearly see they are approximately equal to each other. And approximately this angle is equal to 120. Approximately, okay? And other thing is this force, F4 force is into the direction of diagonal of F1, 2, 3 and 5. No? This is 3 and this is 5. Make a 3, make a 5 anything. So බලන්න ඒ දෙන්නගේ මේ නැන්දොත් එහෙම ඒ දෙන්නගේ මේ diagonal එක වගේනේ පුතේ මේ ඉන්නේ. So according to this figure, you can assume these two angles are approximately equal. Therefore, if you consider the resultant of F3 and F5, definitely it should be into the direction of F4. And තේරුණාද? දැන් මේ F3 එකේයි F5 එකේයි resultant එක ගොඩක් වෙලාවට මේ direction එකට වෙන්න පුළුවන්. හරිද? As they are equal in magnitude, an angle is 120, their resultant should be equal to one force. So now the force into F4 direction, now it is something like this. F4 was the vector. Therefore, then I can eliminate or omit these two forces. One is F8, other one is the resultant and F4. Therefore, I can cancel out these two. Then there will be only two forces. One is very small force F7. Other one is very large force F1. Therefore, definitely the resultant should be very closer to F1. Because it is the large force. Therefore, the resultant, most probably the resultant should be close to OC direction. තේරුණාද? තේරියම්? ගත තේරෙනවද? ඒක ගත්ත හැටි තේරෙනවද? In this case, you have to use your ruler. Ruler එක use කරන්න. ruler එක use කරාට පස්සේ equal and opposite ඒවා කපලා දාන්න. ඊළඟට හොඳට බලා ගන්න අපිට තියනවාද කියලා equal මේ size vectors with some angle. If there is equal size vector with some angle, that means the result should be through its bisector of the vertex angle. Okay, it is through the diagonal, because as it is rhombus, definitely it should be a bisector to that angle. Okay, therefore, likewise we can minimize the vectors into a one vector. Okay, තේරුණාද මේ වගේ question එකක් આવත් කරන්න කොහොමද කියලා? Okay, now it is 10:30 no? හරි. අද මම අන්තිමට පොඩ්ඩක් තටක් ගාලා කරා මේ ඒ මොකද ඕගොල්ලන්ට මොකක්ද අනිත් ඊළඟට මේ questions වලදී ඕගොල්ලන්ට උදව් වෙන්න ඕන නිසා අපි ආයෙත් දාගන්න ඕන දවසක් මේ ටියුට් එක කතා කරන්න. මොකද ටියුට් එක තව කතා කරලා නැහැ. ටියුට් එක කතා කරලා නැද්ද? ප්‍රශ්න තියෙනවා කතා කරන්න. ගොඩක් දේවල් තියෙනවා. හැබැයි ඒක ඕගොල්ලන්ට worth වෙන්නේ ඕගොල්ලෝ homework විදිහට ටියුට් එක කරන් ආවොත් විතරයි. Otherwise it won't be what we be helpful for you. හරිද? ඒක ඕගොල්ලන්ට helpful වෙන්නේ නැහැ. helpful වෙන්න නම් අනිවාර්යයෙන් ඕගොල්ලෝ ටියුට් එක කරලා තියන්න. ටියුට් එක කරලා තියෙනකොට ඔයා දන්නවා හිතපු විදිය. හරිද? ඔයා මෙතෙන්ට අවිල නෙමෙයි හිතන්නේ. ඔයා මෙතෙන්ට අවිල හිතුවොත් එහෙම ඔයාට ඔළුවට යන්නේ නැහැ පුතේ. ඒක නිසා මුලින් ටියුට් එක කරන්න. ටියුට් එක කරලා try කරන්න. මෙතෙන්ට ටියුට් එක නොකර ආවොත් ඔළුවට යන ප්‍රමාණයට වඩා ගොඩාක් ලොකු ප්‍රමාණයක් ඔළුවට යනවා පුතේ ටියුට් එක කළා આવොත්. හරිද? ඒක හොඳට මතක තියාගන්න. මොකද ඔයගොල්ලෝ හිතලා පාත්තයක් එක්ක ඉන්න. පාත්තයක් එක්ක ඉන්න. දැන් පාත්තයක් මුත් නැතුව આવොත් එහෙම අර නිකන් බණක් අහනවා වගේ නේ පුතේ. තේරුමක් නැහැ. හරිද? හොඳයි. අපි මේ තව දවසක් දාගමු මේකට වෙනම දවසක්. මේ ඉතුරු ටික කතා කරන්න. Okay. Next Friday අපි එතකොට heat lesson එක පටන් ගන්නවා. 8 7 to 10 7 to 10 තියෙන්නේ heat lesson එක. එතකොට ඒකට වෙනම you should bring a separate book. The heat unit will be started from Friday onwards. So after that, actually after this Friday there will be lot of works to be done. Okay, therefore don't keep your balance works. Please complete your balance work puta. Okay, so let's complete our today's class. Everyone, good night. Welcome puta. Good night, Putih. Thank you.